We have a unique panel today that includes presentations and discussions to follow on climate change, policy of climate change, and economics of climate change and its consequences. So I would like to show you a little bit about a few findings that we have published with members of our panel here in the assessment of the Bank of Greece on climate change. So can I have the first slide, please? The next, please. So here you can see the occurrence of extreme temperatures from the Athens observatory every 30 years. Is there something wrong? Yes, thank you. Which shows that in the beginning of the 20th century, we had less than 5 cases exceeding 40 degrees centigrade as a value in the summertime. The max temperatures now exceed, there are 15 cases, which means that every other year we have one incident. Here are the forecasts for the future with the ensemble, the Cortex ensemble of IPCC, and one can see that things will worsen. Very difficult to meet the Paris Agreement targets. These are temperatures expected, as you see from left to right, from now, actually from the normal period of 1971 to 2000, up to 2021 and 2050. And then to the end of our century, where you can see in the lowest right slide how things are becoming quite hot, particularly in northwestern Greece and in Turkey, southwestern Turkey. The case for precipitation is also quite worrying about this area. In the lee side of the mountains, we do expect that the decrease of rainfall shall continue, and we lost already 20% of our rainfall in the west part of Greece, and we are going to lose something around 15% in the coming 100 years. These are scenarios, different scenarios, from doing nothing or doing a little. And of course, the changes in the past 100 years, time has almost passed. We have done changes that you can see them here as listed, changes that are striking because we have changed everything, not only the population on our planet, but even the redistribution of land use, of emissions. We have done damages to the ozone layer, important damages and important changes in the greenhouse gas concentrations. So, knowing that this is a preamble to our distinguished panel, I would like to pass on the podium. There's no podium, actually. The floor to His Excellency Yasuhiro Shimizu, His Excellency the Ambassador of Japan in Greece, on global environmental challenges.
Thank you.
Yes,
Thank you very much. And my name is Yasuhiro Shimizu. I'm ambassador of Japan to Greece, but I'm not really the career diplomat. My background is rather environment. I joined the Environment Agency in 1980, and since then I was involved in the many negotiations, including the UN Framework Convention on Climate Change and the Kyoto Protocol and the others. So I'm very happy to discuss this issue with you. And today I'd like to talk about, since I'm the first person to present here, touch upon a little bit the basics of the climate change policy, and then I would like to introduce the recent, very impressive speech by Japanese Prime Minister, Mr. Abe, who made a speech at the World Economic Forum, that is Davos. So, and then if time allowed, some other issues as well. And this is the very, very basic, everybody knows. It's a carbon emission from the man's activities. Before the Industrial Revolution, there is very little, but after the revolution, the Industrial Revolution, very steep increase of the carbon emission released. And in the past, the main emitter was the developed country, but this is the current emission. In 2015, the totally 32 billion tons of the carbon dioxide are emitted. First, the biggest emitter is China. It's more than 1/4. Followed by US, EU, India, Russia, Japan, and Brazil. So that is the current situation, and we need to do something. This is the prediction by the IPCC. It's fifth assessment report. So we would see the temperature rise maximum 4.8 degrees if we don't do nothing. And to respond to this, international community has created many frameworks, including IPCC, the some of the scientific scientists group, and UNFCCC, which I was engaged in the negotiation. It gave the framework of the global climate change policies, and also Kyoto Protocol. And Kyoto Protocol will expire to 2020. So after 2020, we have a Paris Agreement. And the merit of the Paris Agreement is the every country, including the developed and the developing country, are joined. So under this agreement, we are ready to act now. And the recent COP meeting in Poland seems to be very successful. And again, this background, I'd like to say Japanese Prime Minister's speech in Davos. Mr. Abe was invited to Davos after 5 years interval, and he made a speech mainly on climate change. This is very rare occasion for the Japanese Prime Minister to do this kind of a thing. In his speech, he recognized the recent IPCC 1.5 degree report. That means the global net human caused emission of CO2 should reach net zero around 2050. Meaning that any remaining emission would be needed to be balanced out by the removal of the CO2 from the air. So natural process like ocean or forest is absorbing carbon emission, and we are, the limit of the our emission is that level. That's the meaning of the IPCC report. This is the conclusion of the IPCC report. That is the emission scenario by each year. If we are to keep the increase of the temperature maximum 1.5 degrees, we should follow this kind of emission path. So it means the net emission should be 0 by 2050. And after that, the removal is needed. It's a very drastic thinking. And well, we in Japan are now thinking about this kind of emission target and the trend. And by 2050, our target is just 80% reduction. That would balance the emission and absorption. And recognize this kind of very severe situation, our Prime Minister, Mr. Abe, made some good initiative on the innovation side. The first, he said the CO2 could well be best and the most affordable resources from well, multiple uses. That means the CO2 can be used as a material by using the photosynthesis process. That is one of the innovations by Japanese well, scientists. So Mr. Abe said that he would like to well, start an initiative of like this. And also the hydrogen, the cost of hydrogen is very high, but if the cost of hydrogen became the 1/10 of right now, it could be cheaper than the natural gas. So in that period, maybe a very revolutionary thing happened in the well, energy structure. So he said that he utilized a G20 meeting in Osaka this year, June. He would like to start initiative. And another thing is the green investment. Of course, these climate change policies should go with the economy as well. So we initiated the kind of well, disclosure project in compliance with international standard, and EGS investment, that means environment, society, and governance investment should be promoted. So this is another initiative. And there are many chances of investment in a green economy. Well, one estimate said 9 trillion US dollars market will be open if we make initiative on the climate change. And the other issue is we should talk in the Osaka G20 meeting is the ocean plastic issues. This is also a very important issue, well, apart from the climate change. In the sea, the microplastic pollution is now going on. So Mr. Abe talked about he would start initiative by using the G20 meeting in Osaka in June this year as well. So maybe I don't have much time. So, well, in conclusion, I would say well, Mr. Abe, Prime Minister of Japan, fully understands the significance of environmental issues, including climate change, ocean ecosystem. And we are ready to exercise our leadership using the G20 meeting Osaka in June this year. And thank you very much.
Thank you, Your Excellency. Our next speaker is the Secretary General of the World Meteorological Organization, Professor Petteri Taalas, who will speak on climate disasters and their impact. Thank you, Your Excellency.
Thank you, Christos, and thanks for the invitation to attend Delphi Forum. It's always a pleasure to be in Greece. I've been here dozens of times, both professionally cooperating with Christos and his colleagues, and also we have had several nice holidays here, so it's a great pleasure to be here back. So I'm leading a World Meteorological Organization in Geneva, which is a UN specialized agency on weather, climate and water. And we are the founding father of IPCC, and we are also hosting the IPCC Secretariat in our building, and we have been also contributing to the establishment of UNFCCC, which is running the climate negotiations, and now I'm very much advising Secretary General Guterres on climate matters, and he's going to host Climate Summit the 23rd of September this year, and I'm also leading the science advisory group of that event. And we have, for example, established a global network of observations based on ground-based satellites, balloon, aircraft, and vessel measurements. And we are very much dealing with global climate observations and research. My colleague Guy has been leading our World Climate Research Program Advisory Board, and we are also dealing with operational services and Earth system observation, and we are setting standards for that. There was a recent study which UN agencies are innovative, and we were ranked as number 3 when it comes to innovativeness of our work, and we are very much a scientific and technical organization, and we are happy to be in this leaders corner of the UN family. Ambassador just mentioned that Prime Minister Abe was speaking at Davos, and at Davos, which is a sister organization to Delphi Forum, they estimate every year what is the biggest risk for global economy, and for the past 3 years they have estimated natural disasters, failure in climate mitigation, and things that we are dealing with here. They are biggest risk for global economy. So this is also understood by the economic community nowadays. And we have seen a major increase in the amount of big natural disasters, and this green area here represents storms, and the blue area here represents flooding, and orange heat waves and drought, and you can see quite impressive increase during the past 30 years. And if you look at what is the distribution of disasters for the past 10 years, about 91% of the disasters have been related to weather, and we have seen that half of the world's population have been exposed to major natural disaster during the past 10 years, biggest being flooding, and number 2 being drought, and this drought has been hitting especially African countries and some parts of North America. And if you look at losses for the past decades, first on the left-hand side we see the human losses, and you can see that there has been a really nice development. We are losing much more human lives because of disasters, and that's very much because of improved early warning services. But if you look at this right-hand side of the graph, you can see that the economic losses have been dramatically increasing, and during the past 30 years we have seen a tripling of the economic losses related to those disasters. And most expensive disasters have been hitting USA, and they have seen in the Caribbean area. There's also flooding that has been hitting China and Thailand, and if you divide these disasters according to the size of the economy, there have been several hundred % GDP losses annually on the small Caribbean islands. For example, Dominica lost in 2017 250% of its GDP, and in 2015 they lost 90% of their GDP. And since the frequency of these events may be increasing, it's quite alarming for such countries. We have seen the warming taking place so far about 1 degree, and the largest changes have happened in the Arctic, and over the oceans we have seen about 1/2 degree warming, and actually we have stored more than 90% of the excess heat to the warmed oceans. And the Arctic winters have been warming 3 times the global average. And another other region where you can see warming, especially in summertime, which was also shown by Christos, is the Mediterranean region. And last year was the warmest La Nina year. We have this El Nino La Nina variability, and which is having an impact on global temperatures. And this year we expect to see weak El Nino, which may mean that we will have a warmer year than last year was. But this is showing that the climate change is still proceeding. And the biggest economic and human impacts are not related to temperature increase, but they are related to the changes in precipitation patterns. And for example, Africa has been facing much more drought, and also southern parts of part of Asia and some parts of Amazonian rainforest have been facing drought. At high northern latitudes, we have seen an increase in the rainfall amounts. And WMO publishes an annual basis status of climate report, and we also work together with IMF, and IMF estimated that there has already been an impact on global economy because of climate change. There has been a negative impact in southern hemisphere and low latitudes of northern hemisphere, and positive impact at the high northern latitudes because of higher temperatures and higher amount of precipitation. We have seen 26 centimeters of sea level rise so far, and this still continues. And by 2060, we expect that several parts of the world will be exposed to challenges related to sea level rise, and especially big Asian countries, China and India, have lots of population who are living in the low-lying areas. But there are also other places like New York or London. And we have already melted 75% of the Arctic sea ice mass, and the melting has also started in the southern hemisphere, not as extensive as in the north. And these dramatic changes in the Arctic, they are also having impacts on weather patterns outside of the Arctic area. Some of the unusual winter weather patterns and heat waves in summertime, they are related to the change in atmospheric dynamics. And WMO is measuring the greenhouse gas concentrations, and so far we have seen about 150% increase in carbon dioxide concentration, about 260% increase in methane concentration, and most important of those is clearly carbon dioxide, which contributes to 2/3 of the warming so far. And the lifetime of carbon dioxide is up to thousands of years. So that's a major problem when we talk about climate change. And the ambassador was already showing the emissions. I would like to pay attention to the fact that also the emissions have been growing fairly rapidly in non-OECD countries. It's not only the industrialized countries and China, but it's also outside of those countries. So it's a global challenge. And to me, the major risk related to climate change is related to the food production capacity of our planet, and we are at the risk to lose large parts of food agricultural productivity capacity. And you can see also the Mediterranean region as fairly reddish because of that. And finally, what is the challenge ahead if we want to reach 1.5 degrees or 2 degrees target? We are at the moment producing 85% of the global energy based on fossil, and only 15% based on nuclear, water, hydro, and renewables. And we should revert those numbers within the coming decades. And finally, we have seen the negative trend in carbon dioxide emissions to continue. And last year we were again breaking a new record. So the implementation of Paris Agreement is not on track, and it's a major challenge for the future generations. Thank you.
Thank you, Your Excellency. We have the pleasure to hear Professor Guy Brasseur. He's director everywhere. Yeah. From the National Center for Atmospheric Research in Boulder to the Max-Planck Institute in Hamburg, etc. So we're eager to listen to climate change and air pollution. Time for action.
Yes, thank you very much for the very kind invitation. I would like to go relatively rapidly over a number of issues. And the first point that I would like to make is that the climate system, first of all, it's a system, and it's a dynamic system. It's a system that is in perpetual evolution. And if we look at the past of the evolution of climate in the Earth, we see that it has not been a quiet history. There's been a lot of variation that are, of course, recorded in the ice. And we see here, for example, those fluctuations over the last 400,000 years that indicate that at the same time temperature and CO2 and other greenhouse gases has been evolving. And if we look carefully about what happens in the last 100,000 years, we saw that most of the time we were in a relatively cold situation with temperatures that are 6 to 8 degrees colder than today in the geological period that we call the Holocene, which is a bit of an exceptional situation. But of course, since in particular the mid of the 20th century, we have seen a shift in the evolution that brings us outside the range of natural variability. And this great acceleration that is shown here, showing you that the human enterprise has been changing the situation drastically with, first of all, change in population, economic growth, but also urbanization, globalization. And you see those exponential curves here that shows the socioeconomic trend that have been a kind of a new era. Sometimes we don't call it the Holocene anymore, but we're talking about the Anthropocene, the geological period dominated by human activities. That has, of course, global impacts. The greenhouse gases concentration, we talked about ozone depletion, climate change, but there are many others. Biodiversity is changing, coastal zones are being eroded, and you see that the impact are also have a nature of extreme rapid growth. So today, the forcing is really associated with the emission of greenhouse gases, and you see here on the one hand that it is, as indicated earlier, very distributed around the Earth. The largest producer of CO2 today is China, but of course it is because the population is very high. If you look at the emission per capita, then it sees Canada is number one, with the United States following. And so these emissions, of course, have immediately as impact to produce kind of a blanket around the Earth and capture the energy that is released by the planet as opposed to let it go to space. And in fact, more than 90% of the heat produced by the greenhouse effect is stored in the ocean. And this is why the response of the system is very slow. The ocean has a lot of inertia into it, and this is why an action today will have an impact tomorrow quite far away in time. This is also why actions need to be taken much before the effects can be felt. Now, of course, one of the way the energy is stored is to increase the surface temperature. And you see here the evolution of the temperature as recorded, but also as modeled, as a function of time between 1850 and present time. And you can see that the models that try to reproduce this evolution cannot be successful unless they take into account the increased emission of greenhouse gases. The impacts, of course, are important and are growing as a function of the level of warming. You see the gray line, which is the current warming compared to pre-industrial, almost 1 degree on the planet. And you see that already we see effect, for example, on the coral, in particular the tropical region. But you can see also that in many areas, the impact will be growing as the temperature becomes more higher. Now, it is not so much the mean temperature that is of concern, but essentially a number of systems at the regional scale that could be disturbed substantially. Tipping point element, places where you could have a number of interesting and abrupt changes that are occurring. Like, for example, we see the ice melting very strongly in Greenland. We see big effect in the Amazon and other places on the world. Tipping point element, how are those going to change? And so this is a question as we look at future climate change. Well, we don't know exactly how much we're going to emit. But so we're going to look at scenarios. And I'm going to insist on two of them. The first that is called RCP 8.5, which is basically business as usual. And the other one, on the other hand, RCP 2.6, which is drastic action to limit the temperature increase on the average of 2 degrees. And, oops, I was going to, well, it won't work. So I'm going to show you that this was a movie of a film. But essentially what you see is on the left-hand side, the natural evolution of the temperature. And you see the fluctuation that I mentioned earlier. But now with the projection we have in mind, we are really outside the range of the natural fluctuation. We are committed to limit it to 2 degrees. But it could go higher up if we do not take action and really move the Earth system in a very different state. This is a challenge for the contemporary simulation, and those tipping points that I mentioned might be flipping into other situations in between, basically those 2 degrees or 5 or 6 degrees, with a number of changes that would cascade into the Earth system, and some are indicated here. So climate change is really caused by two things. It's caused by human activities, but it's also caused by human inaction. And so I would like to say that we need to take action. It's important to start today. You remember I mentioned to you this fluctuation between glacial and interglacial systems that are shown here. You see where the Earth was in the Holocene, outside the cold temperature on the left, this valley of stability of glacial side. But now we are moving. And so the choice for us is to see if we want to bring it in a stabilized area, so a stabilized Earth, or on the other hand, if we want to let it go and move into what is called a hot house Earth, that would be a very different civilization and a different situation. And that is the choice we have in front of us and we need to do today. So we saw this graph, the ambassador showed it earlier. If we want to be in a sustained situation, we have absolutely to reduce the emission of carbon dioxide to close to zero in about 2050. This is a challenge, enormous challenge for our civilization. A large transformation needs to be done. And of course, this is what we should really be discussed. How are we going to achieve that if we want to stay outside the hot house dramatic situation that I showed earlier? And of course, there will be a lot of actions to be taken to address the sustainable trajectory for our planet. Some are listed here. I'm not going to talk about them. So this is a big challenge for us. But we have other challenges in the environment. And I would like just to mention one that is related, because it's kind of the sources of the problem are very similar. Air pollution. You know that according to the World Health Organization, it is a major societal problem today. 91% of the world population breathe air that is in the pollution concentration higher than the adopted standard. 4.2 million people die prematurely every year from air pollution, among which are 600,000 children. And if we look at the impact, for example, on crop production is reduced considerably. We're talking about more than 10 or 20 billion US dollars. So air quality degradation is an important issue at the moment. And if you look at the mean reduction in lifetime in the world, it used to be 1 year in 1998. It is now 1.8 years. It is the largest reason for basically premature death before smoking, before many other diseases that retain the attention very much. And in fact, if you look at the time, the reduction in life, 1 to 2 years in the OECD country, but it can be much more than that in other parts of the world like China and India. We see today air pollution from space. You see it over Europe, over China, over the Middle East, and we have now the means to know what to do and how to reduce this. It is to reduce emission, just like we do with the greenhouse gases. So, time for action. Time for action to limit emissions that lead to air pollution, but also to limit emissions of greenhouse gases, in particular CO2, that lead to climate change, a major challenge for our society.
Thank you, Guy. So we now proceed to a mystery talk. I have no title. Professor Pantelis Capros from the National Technical University, who will give the lead to the economic consequences and balances and imbalances with models. Thank you.
Thank you. We heard about the threats, and I'm going to talk about the ways of reducing drastically the greenhouse gas emissions, and in particular in Europe. You know that it is now more than 10 years that the European Union presents commitments and very analytical studies called often roadmaps of how to reduce greenhouse gas emissions drastically in Europe. And we have been doing with our primes mathematical model all these roadmaps published so far by the European Commission and the European Union and have been included in the legislation. So this primes model is doing the analytical work in detail about how the European energy system is going to be transformed radically and with which measures and policies is it possible to do it. So the last piece of this work is the long-term strategy called by the European Union Clean Planet for All, that was published end of November 2018 and has been based also on the primes modeling that we are doing. And for the first time, this strategy, long-term strategy, tackles the issue of getting the European energy system to carbon neutrality, zero emissions, as it has been required by IPCC in the context of the 1.5 degrees requirement. So it's extremely important. And if you see all the previous roadmaps, one can very easily see that the emissions that are difficult to abate are the emissions that are related to transportation, liquid fuels used in transportation, and natural gas, in particular, used in stationary energy uses in buildings and industries. So how to do it is a major issue and has never been studied in Europe in so much detail as in the publication of the Clean Planet for All, which is going to be announced officially this year by the head of states as the strategy of Europe of the future, and will go into legislation in the next stage. So the basic storyline of decarbonization is about the two pillars: energy efficiency in all sectors, renewables, the second and equally important pillar, and the role of electricity. Electricity plays a critical role in this transition because it is possible to decarbonize power generation in the early stage of the transition and use electricity as a carbon-free carrier to decarbonize sectors that otherwise are inflexible in abating the CO2 emissions, like in transport and heating. However, the new thing in this long-term strategy is that to go up to full carbon neutrality, we need something in addition compared to the conventional wisdom roadmaps that have been published up to now. And this is the new element introduced by the European Union in this long-term strategy, which is original and novel and extremely important. And the whole strategy is shapes the policies and measures in two categories. Those that are considered as no-regret options, and they concern energy efficiency, electrification of transport and heating where it is cost-efficient to do it, enhanced renewable power generation. In fact, you know, up to now, years ago, there was discussions about development of nuclear and CCS. Both of them in Europe have trouble to develop, not so much for economics, but mainly because of the social acceptance and the difficulty of getting licensing of sites to develop nuclear and CCS. As a consequence, the only and vital solution to decarbonize power generation in the early stages are renewables. And we're talking about renewables at such a large share in the future power generation that requires novel ways of integrating the renewables at a very large scale. And this is the very important element introduced in this long-term strategy, the storage systems, the flexibility, the demand response, and the as broad as possible integration of the markets and the grids in the European system. But this conventional wisdom, no-regret approach is not sufficient, as I said already. In order to go into carbon neutrality, we unfortunately need disruptive changes. And the dilemmas of the strategy are about which are going to be the disruptive changes. All the disruptive changes involve technologies that are not yet mature. So it is not easy to make decisions at this stage. The issue and the role of this strategy is to prepare the ground of exploring the different options and be ready to take decisions about the winners of the disruptive changes not more than in 10 years' time. And this is about, you see, there are 4 stylized disruptive changes studied in this long-term strategy. One is maximum energy efficiency and circularity of the economy beyond the conventional energy savings, insulation of buildings, etc., much beyond that. We demonstrate through very detailed mathematical simulations that it is possible, not only in the energy, but also in the economy, through the reorganization of the economy as a circular economy. However, a lot of uncertainties still are not resolved about how to do it and what is realistic regarding the cost of transformation along the path of maximum efficiency. Second, maximum electrification. Use electricity everywhere. It is technically possible. We simulate in detail how to do it. Has the advantage of to be a very efficient scenario from an energy perspective. However, we still have a lot of uncertainties regarding the maximum electrification for example, how it is possible to have a number of transport market segments fully electrified, trucks, aviation, maritime, very difficult, possibly impossible, and also fully electrified high temperature furnaces and other uses of heat in industry. So this is possible, very efficient and less costly than others, however, uncertain regarding the extreme technology. Third, hydrogen. Hydrogen economy. Hydrogen as a carrier and a universal solution in the economy. It is technically and economically feasible. we demonstrate that there are tremendous benefits to integrate renewables also in the power sector because of the power to hydrogen technology. However, the uncertainty here is regarding the universal distribution and storage of hydrogen, because this requires transformation of a huge grid system into hydrogen and the final use equipment to comply with the Wobbe index of combustion of hydrogen. And the fourth is the strategy of preserving the current paradigm of using energy, liquid fuels, gas fuels, and distribute them. However, change the origin of the molecule. And the molecule is methane and hydrocarbon, gas and liquids. To change the origin, we have to produce synthetic gas and synthetic liquids from hydrogen produced from renewables, and then capturing CO2 from the air or biogenic resources and synthesizing them into gas and hydrocarbon. This is a very promising technology. Today is uncertain regarding the maximum learning by doing potential it may have. The advantage is that we have the paradigm of energy use unchanged. So these four strategies are explored through a large number of scenarios that you can see in the internet, not only the stories, but also the numbers. If this presentation is distributed, you will be able to see in detail all the numbers of the different strategies and how they compare to each other. So I go directly to the conclusions, and I'm going to talk about the costs. The total energy system costs are higher than baseline. This is fully expected. However, all scenarios involve costs of the energy system as percentage of GDP decreasing over time, thanks to the maturity of the new technologies and the positive externalities enabled by the huge technology transformation. That is the future of Europe, to get first mover advantage in the world scene of technologies, and also to get employment and new activity through energy. The average price of electricity is possible to remain at reasonable levels despite the tremendous transformation and an 80 to 85% renewables in power generation with the new storage facilities. Investment is extremely important. So all this transformation is very capital intensive. It is about replacing imported energy by domestically produced equipment. And this requires 1 to 1.5% more investment as percentage of GDP than business as usual, which is a very big effort in investment terms. So I conclude saying that this long-term strategy simulated in detail confirm the central role of electricity and expand also electricity as a feedstock to produce synthetic fuels and hydrogen. Renewables is the only solution anymore in power generation transformation, and the role of hydrogen and synthetic fuels is extremely interesting in providing the sectorial integration, the sectorial coupling. The new word here in the strategy of the European Union is sectoral integration. There are many, many examples and studies, and you will see a lot of new legislation and initiatives to support this sectorial integration that is the key of the transformation of the energy system. Thank you.
Thank you, Pantelis. We now move to our dear lady, Professor Phoebe Koundouri. She will tell us about interdisciplinary challenge of implementing sustainable development. Phoebe.
Thank you, Professor Zerefos, for bringing together such a distinguished panel. Can I have my presentation on the... Okay. It is important, the composition of this panel is important because it shows the need for interdisciplinary work in order to solve problems that have to do with climate change and environmental degradation. And the last 25 years, I've been trying to develop the network of researchers and expertise in order to derive solutions on climate change, adaptation, and mitigation that are interdisciplinary solutions, because only through interdisciplinary solutions you can actually solve the problem. We are past the era that each discipline was doing its own thing, and then we could not have relevant solutions for implementation that could have an effect on the economy, the society, and the environment. I chair two initiatives within the country that are actually global and European initiatives, the United Nations Sustainable Development Solutions Network and the EIT Climate Kick Initiative, and I will tell you what we try to do with regards to those initiatives, which are very focused on science-driven solutions and their implementation within the country. So, as an academic, I always start from the definition. So we all know what sustainable development is, but it's important to have it in our mind just to keep the focus on the interdisciplinary nature of the problem. It is basically an organizing principle for meeting human development growth that allows nature and ecosystem services to be produced in a way and consumed and used in a way that it is sustainable. Why do we care about them? Well, at least because our economy and society depends on them. To be sustainable, you need to be environmentally sustainable, you need to be economically sustainable, and you need to be socially sustainable. When I first lectured, when we introduced sustainable development, we always said it was about future generations, being able to meet their needs in the same way that the current generation does. But it's not anymore, it's about this generation. If you look at the October IPCC report, we have another decade to get our act together and really take action. The previous speakers showed evidence of the climate change phenomenon. They showed evidence on the urgency of the situation. We have the report that says that unless we take action today, then the risk from droughts, floods, extreme weather conditions are increasing dramatically in 10 years, and the situation will be irreversible. I'm here to claim that we have the technology, and we have the science solutions, and we have the economic resources to make the change. The change needed is unprecedented, both technologically and economically and socially, but we are able to make the change as long as we have the will. And it is transforming our world 2030 agenda of the UN that tries to map our goals within this 17 Sustainable Development Goal is not a scientific agenda. It's an agenda to be communicated to all relevant stakeholders and just organize the discussion. And I believe in it just because it's easy to communicate. Here in Greece, we're not doing very well, but we're doing well in two sectors, climate change and renewable energy. And this gives hope. And this does not put us very far behind from the regional average of Southern Europe. What does the United Nations Sustainable Development Network do? Well, it's a global network that tries to bring together the results from us scientists, natural scientists and social scientists to the rest of the stakeholders who have to be engaged, who have to understand what is going on in order to be willing to be part of the solution, to implement the solution. So we started this big effort to try and talk and communicate the solutions, the results, and the implementation, sustainable implementation plans to businessmen, to policymakers, to politicians, to the civil society, NGOs. And it is a difficult exercise because it's easy to talk to your fellow scientists and present your results. It's difficult to produce solutions that are implementable, but also embraced by the stakeholders who have to implement them. The Sustainable Development Solution Network on Greece has a huge network of research institutions, more than 3,000 research institutions in inland and abroad as member. Almost all universities and research institutions of the countries are member, and also a big network of companies and NGOs on which we focus in order to communicate scientific solutions that are readily implementable for solving climate change problems. Our cross-cutting themes is valuing nature and integrating this value into investment allocation so that investment decisions are sustainable, climate change adaptation, mitigation, and sustainability in times of crisis. We particularly focus on green shipping, sustainable marine use, marine resources use, sustainable food, water, energy nexus, energy security, sustainable biodiversity and tourism, and of course, importantly, education and training in sustainability. And this is the cluster of coordinating institutions, I would say. The Sustainable Development Solutions Network is hosted by PETS, Political Economy of Sustainable Development Laboratory at the National Capodistria University of Athens, and I create a research center on the economy and the environment, and also and these institutions collaborate very closely with Athena Research Center, which is an innovation research center mainly focused on information technology solutions, a laboratory at the Athens University of Economics and Business that I can direct on sustainable environment. It's called RESEAS, and it's research on socioeconomic and environmental sustainability. And at the same time, we have with us the people who do the bottoms-up approach and talking to the stakeholders. Convergence World Economic Forum, led by Alexandra Mitsotakis, and the Natural History Museum, Gouladris Natural History Museum, who has been for more than half a century the main educational center on the environment in the country. This is where our projects are distributed. At the moment, we have more than 100 researchers inland and abroad, mainly doing work within Europe, but also around the world, focusing again, as I said before, on marine and coastal management, forest management, waste management, inland water management, biodiversity, and so on. Our, let's say, important point that I try to communicate now, and even if it's a bit scientific, I will try to do this because there are many scientists in the audience, is that we try to capture in scientifically sound ways the total economic value of natural resources and other public goods and incorporate this total economic value in allocation and management decisions. So we try to increase social welfare by understanding the framework of analysis. So each problem is a case study for us. We identify the natural resources, the socioeconomic resources, the institutional resources, the stakeholders, and then based on this framework, we develop models of interaction between nature, society, and the economy, and then we apply these models that allow us to derive the total economic value of each and every resource, natural resource, man-made capital, and human capital. And once you have the values of the inputs in the growth, in the production function of the economy, you can allocate these inputs in a way that is optimal for social welfare, and it is at the same time sustainable for the economy, the environment, and the society. And the solutions, once you have the allocation, you can implement the allocation using solutions. These solutions can be economic instruments, legal instruments, technological innovations, social innovations, nature-based solutions, and so on. And then we create the management plans. It is important to understand that the value derives from the value of natural resources derives from ecosystem services, the services that the ecosystem provides the society with. And these ecosystem services are translated into human benefits, and these human benefits are then monetized. Once you have them monetized, you can include them in investment allocation plans, in economic plans, and you can make optimal allocation of resources that is sustainable. Uncertainty is a huge issue. There are many things where we have ambiguity about the total economic value, but this is something we are working on, and uncertainty is the framework of analysis for science. Uncertainty is what drives science. So there are issues there, but there is a lot of progress, a lot of results that needs to be integrated in implementation solutions. The other initiative that we have among the many is that we are the hub for Climate Kick, which is the main transformation initiative into climate, for climate change of the European Union. It's focused on transforming innovation into climate action. It is supported by the European Institute of Investment and Technology, which is a knowledge and innovation community, and we try to accelerate the transition to a zero-carbon economy through whole systems transformation. These are the results of the 10 years let's say, functioning of Climate Kick at European level. So the basic 4 principles, what we are doing as Climate Kicks, and there are 28 Climate Kicks in the 28 countries of Europe, is convene networks of expertise, leverage grants smartly and efficiently, develop people and capacity, and catalyze innovation. And you can see the results there. More than 300 partners, more than 550 million, leverage in startups acceleration, more than 1,000 startups, 2.5 million leverage for climate funding, more than 2,000 jobs created, more than 17,000 participants. This is the consortium of the local KIC, Athena Research and Innovation Center, where I affiliated this project and I directed from. The Academy of Athens, Professor Zerefos Group, Unifund, which is one of the major European funds that is supported by the European Union Fund, Equity Fund in the country, ERFC, an NGO, the Sustainable Development Solutions Network, the Foundation for Economic and Industrial Research of the country, supported by the enterprises, the Association of Enterprises of the country, and Unis Energy Group, which is an energy group with a very successful, fully renewable island case study that we want to replicate. The whole thing is supported by the government and the Ministry of Environment and the Greek Fund. 3 initiatives, acceleration. We have now the acceleration results. We are accelerating 5 companies. One of them is about hydrogen and energy production. Second initiative, pioneers into practice, professional mobility within Europe for better training for professionals in the energy sector and the shipping sector. Climathons, a big event, 24 hours all around the world. Cities identify a climate-related challenge, and they run competitions for solutions, implementable solutions for this challenge. We run many events, conferences, training courses, workshops, e-platforms like the United Nations Sustainable Solutions Network platform, which has more than 1 million students, and the best of the best teaching there is freely accessible to everybody. The idea here is that knowledge creates value and engagement. You might develop as a scientist, the scientific community, the best possible solution. Unless the stakeholders are convinced by this solution, you will never get implementation. And there is an urgent need for implementation. I have here various highlights from projects that we have within our research network, UNSDSN, but I won't go in detail in them. I will just say that we think it is important, like it has been previously said, to start acting now. And as scientists, we understand the difficulty of acting within an uncertain framework, but we have no luxury of waiting anymore. Things that are coming soon from this network, other than many reports, papers, and books from our research project, is a new MSc at the Athens University of Economics and Business on energy law and economics, Greek sustainability report, and the Sustainability Summit that is going to happen every year in Athens, bringing together all the stakeholders that need to listen to scientific results on climate change and sustainability transition. Thank you.
Thank you, Phoebe. Our next speaker will move us to the prizes. And our next speaker is Tasos Xepapadeas, professor at the Economic University in Athens. And he's one of the group, of our group at the Bank of Greece, which calculated that the cost of doing nothing at the end of this century from man-made climate change would sum up to exceed 700 billion euros, which is double our debt.
Thank
Professor
you very
Xepapadeas.
much. Thanks for inviting me, and thanks for being here. My presentation will deal with the way that we price climate change. As an economist, I had to talk about prices. Now, a question that comes out of this title is, why price climate change? I mean, is there a need to price climate? Now, there are lots of reasons. For us economists, climate change is regarded as the ultimate challenge. And it's the ultimate challenge because we need to understand the way that the environment, the climate, is interconnected with the economy. But not only that, we need also to understand the way that we'll design policies in order to slow down climate change and somehow reduce all the negative effects that some of them were presented before by our speakers. Now, for economists, climate change is an externality. In terms of economics, an externality is something that happens to you because somebody else is causing it, not you. It's the biggest of all externalities. A colleague of ours, Marty Weitzman from Harvard, called it the mother of all externalities. Now, how we deal with externalities? Usually, to correct an externality, we need to impose taxes, carbon taxes, we need to introduce trade and permit systems and things like that. But in order to do these things, we need to price the climate. Now, I will show you some graphs, and some of them have already been shown before, but I cannot stand the challenge. This is really disturbing. This shows that in 2018, CO2 emissions increased by 2.7%. This brings us back to the scenario of the business as usual. And this is very important. This is another graph. This is from the latest IPCC report, the 1.5 degrees, that shows that if we continue with the scenario of the business as usual, we're going to cross the threshold of 1.5 degrees around 2040. It's coming, okay? Another graph here deals with damages. This is the most recent report from the United States about damages from climate change. You see that the top line, the brown line, which is the bad RCP scenario, is related to lots of damages. So in this context, we need to price the climate. And I'm going to talk about two things in brief within the allotted time. The price of carbon to be used to project appraisal, and the price of carbon to finance and to price risks in the financial sector, which is something that has come up recently. Now, when we talk about the price of carbon, we talk about a concept which is the social cost of carbon. What's the social cost of carbon? Intuitively, it's very clear. It's the damages that will be created if we emit a ton of carbon for the whole lifetime that this ton will stay in the atmosphere. And in order to evaluate projects, either because they reduce carbon emissions, like the technology that Professor Capros discussed before, or to evaluate projects which will have more emissions in terms of carbon dioxide, we need that price, okay? How this price looks. This is some estimations from the World Bank, most recent estimates, 2017, that shows basically that the red line is the red line over there is the high price, and the blue line is the low price. Around our time, the high price is around 80 and the low price is around 30. So this is a way to price emissions, to price the cost of emissions, or to price the benefits from reducing emissions. And this is very important if we want to allocate our projects in an efficient way. This is another concept. This is the effective carbon price, which is basically the carbon price that will include any emission permit price, any carbon tax, and any specific tax on energy use. What's important here is to measure the gap between the effective carbon price and the actual carbon price. Okay? And this is, again, very important for policy purposes. Some recent calculations from OECD show that if we set the carbon price at 30 euros per ton of carbon, then we're something like 83% from the effective carbon price, and if we keep that at the 30 euros per ton of carbon, this gap will be reduced. This is the one part. The second part is climate change and financial markets. The Governor of the Bank of England in 2015 introduced the idea that climate generates lots of risk for the financial system. And the idea is how we deal with these risks. If you economy into assets which are brown, okay, carbon intensive, and assets which are green, then you have two types of risks. You have physical risks, were described before, which affect both brown and green, but you also have transition risks, which are the risks as we go to a free carbon economy. And these carbon and these policy risks will affect only the brown assets, not the green. Okay. Let me show you a graph. This is a very, very recent result from a work of mine with a colleague at the Zurich that shows the number of climate disaster events as a function of temperature anomaly. Temperature anomaly is the change in temperature from the baseline. Actually, it's very close to what we saw before. You see that's a very nice straight line, increasing line, indicating that as temperature goes up, these disasters will go up as well. So what does this mean for the financial market? Here, from the same study, I put the risk premia, the spread, if you want, that is coming from climate change. you see that for the bad scenario, the little crosses that go up, the risk premia increase constantly. While for the good scenario of the RCP, the one that we all hope that will prevail at the end, they go down. Another interesting result is the yield on government bonds. These are very important numbers for financial markets, and we design our policy around these numbers. And again, it's indicated that at the bad scenario, the yield is going to go down constantly, while at the good scenario, which again, it's a hopeful solution, it's going to start going up. It's interesting also the right-hand side panel that shows that the yield on government bonds consistently is decreasing at the level of emissions. So all the discussion that we had before, I mean, the free carbon economy, the technology option that Professor Capros discussed, will have a big effect also on the financial system. It's very important to understand these risks and sort of try and stabilize the financial system against these climate risks. Finally, if I have a couple of minutes, I would like to finish with areas that could be areas of further research, some of these that Phoebe's network would study, and also I bring them in the context of the Greek financial system. I mean, we need to understand the exposure of the Greek financial system to carbon. We need to understand whether assets will be stranded and what will be the cost of these stranded assets. We need to understand the liabilities to the insurance system from these financial risks. We need to understand the extent to which assets are not insured for climate risk. We need to study a structure of a potential macroprudential policy, which basically will promote the introduction of new green technologies. The financial system needs to take care about how these new technologies will be financed. It's very important. We need also to discuss issues related to green bonds. Green bonds will be very important to finance and support adaptation for the Greek system. So these are all issues that need to be discussed. We need also to understand and to estimate the discount rate in order to evaluate properly our projects. We need to find the price of carbon. Okay? We need to study the damages of climate change to Greek economy. Professor Capros, Professor Zerefos told us about the study of the Bank of Greece. All of us were involved in this study, and now we're in the process of revising the numbers and getting new estimates. And finally, we need to study the vulnerability of the Greek economy, both in terms of region and both in terms of sectors to climate change. These are very important issues. I mean, it's very interesting and very nice to identify the dangers, and it's very clear where the dangers are coming from. But I think it's more important to understand the way that the economic system, the economy, the social system, and the financial system will react to these risks and how these risks will be taken care if we have prudent and well-designed policies. Thank you very much.
So thank you, Tassos. You have been exactly 10 minutes. So I think it's time to make a wrap-up. It's time to listen to a couple of questions from the floor, from the audience. I just wanted to say, in connection to what Professor Xepapadeas mentioned, is that Greece is proceeding now to implement the adaptation strategy to climate change, to man-made climate change in Greece. We have provided support, scientific support, to the Ministry of the Environment of Greece, and there is an extensive legislation now based on our findings from the Bank of Greece. It's actually interesting to point out that we have preliminary estimates that if we implement the adaptation suggestions from the report of the Bank of Greece, then the cost of climate change would be reduced to about 400 billion euros at the end of the century compared to the 700 billions or more estimated in the previous assessment. So the adaptation programs are on their way. There are 13 prefects that are now all working towards finalizing their reports. And I would like, since I don't see any hands. Oh, yes. Please. You need, yes.
Brilliant panel. Gloomy outlook except for Japan's ray of hope on...
Could you please, Dr. Jackson, give your name and affiliation so that...
Richard Jackson, Athens College. Brilliant panel, gloomy outlook except for Japan's ray of hope on its development. Would the panel care to comment on the President Trump's disastrous decision to withdraw from Paris, if not reversed?
Well, thank you very much for commending my presentation. And of course, Japan is very eager to promote so disruptive development of technology utilizing the G20 meeting. And regarding the Mr. Trump's response to the climate change issue, I have some impression from the negotiation of the UNFCCC and the Paris Agreement that the US is a kind of doing damage controlling negotiation. Current administration is very opposed to the climate issue, but it can be changed. And if the policy changed, US can return to the international agreement. So my impression is that at least the US negotiation team at the COP is doing their best to leave their options. So that's my impression. Thank you.
Yeah, so I think that the public image of USA is worse than what's happening in real terms. There are several states and several cities in USA who have ambitious mitigation plans and mitigation action, and there's a recent estimate that USA has fulfilled half of its Paris pledges already. And from the private sector side, where the mitigation financing is finally coming, the private sector is moving. It's attractive to invest in solar and wind energy at the moment, and that's going to be one of the drivers. But one should keep in mind that there are also fossil-based businesses, not only in the USA, but worldwide, and of course for them, mitigation efforts are not so favorable.
Personally, I don't worry about that, because I think very soon the United States will understand that this is a very dangerous decision regarding the technology competition worldwide, and is already losing in terms of the development of the new technologies. And because, you know, all this climate change mitigation at the moment, and the most promising is that it is about technology competition, technology development competition. So they will change their minds very soon.
Can I add something quickly? In spite of all what was said, we are very concerned by the recent decision of President Trump to appoint a committee to basically design the policy of the climate policy of the US, which is really led by a person who has a past of being a very skeptic, and so we will see what happens. All that being said, it's true that the energy policy and the transformation policy is not happening at the federal government, but it's happening at the state level. Clearly, the US will have to understand that if they do not join the international evolution in this regard, their technological capacity will be behind, for example, China, which is taking a lot of action in terms of protecting the environment and will continue to do so.
And they will create many more jobs using new technologies, which is actually what is said as an excuse for going out from the Paris Agreement. But I think just to close that, in the US there are many states that have exceeded the Paris Agreement. I give an example. One city, San Francisco, 0 emissions, and many others. So not only here. So, Madam, and the last, yes?
So my name is Helena Tsaiki from PwC, Head of Sustainability. Thanks for the very interesting panel. Since we have so many professors here, I just want to ask whether there has been calculated the actual cost of the sectors that they have had already targets coming from the COP21. And therefore, the industry is looking what was going to be the cost of compliance or the measures that Mr. Capros actually mentioned before. You know, we have all these kind of measures coming, and those sectors needs to implement them. So I think the question here is that have we calculated the cost for per sector in order to implement these measures and in order to get the targets? Thanks.
Yes, of course. In the European Commission studies, we calculate the cost by sector since many years and in very detail. But the issue, we don't have time, the issue is not about costs only, but also about the industrial opportunities. Take the example of steel. Steel has a cost now because of the ETS, but it has tremendous opportunities to produce the new kinds of steel integrated, vertically integrated with the automobile, for example, sector, which will produce the electric cars and a number of new technologies. This integration will preserve the steel industry in Europe rather than continuing with the old way of producing steel.
So thank you all. I just wanted to thank the forum here, the Delphi Economic Forum, and Mr. Tsomokos and his collaborators, and also, most of all, thank our esteemed speakers, and note that we are in the center of the earth, where the Delphi Oracle was. But also we are very close to Athens, where actually the term climatology was first used. Klima comes from the verb klino, which means I incline. And inclination of the sun's rays are the decisive factor for differentiating climates. So climate has been used, and they have been described by Aristotle in the first book on meteorology called Meteorological, published 3rd century BC. I now would like to introduce my personal dear friend, esteemed Honorable Kostas Karas, Honorary President of Europa Nostra, and we are privileged to listen to his thoughts